Right. Music rendering in Unreal Engine, the Harmonix music plugin for MetaSounds. Actually, since I proposed this talk back in the summer, we've been able to release this thing called Patchwork, which is a feature of the Fortnite game. I wasn't able to talk about it back when we proposed the talk, but now I can. And so now I can actually give this talk, as I had hoped, in the context of Patchwork. What I want to do is actually talk about how we're able to make Patchwork. Some of you may know what Patchwork is, maybe not many. I'm going to show you what Patchwork is, so this will make more sense. So this is going to be kind of like a quick survey of lots of things. I was thinking about doing one of those classic presentation things where I ask everybody, like, who knows about Unreal Engine? Who knows about video game development? I think the answer is, from the discussions I've had with various people at the conference, that there's a wide range of experiences in the room, and so I'm going to have to cover lots of things at a very shallow level. And hopefully, when we're done here, maybe you'll leave with some good search terms for Google. That you'll find more information. I've been told that I'm a fast talker, and I think that's going to be important here because I've got a ton to cover, so I'm going to apologize right now. I'm just going to blast you all with a fire hose of information, I think, and try to get through lots of these slides. And with that in mind, let me just jump forward, I guess, and into the presentation. This is me. I think if you're a Brit, you have reason to be suspect of your Homeland Security or whatever you call it here. That's my passport photo. They let me in. I'm a musician and recording engineer first, although from the looks of it now, I guess it gets harder and harder for me to say that, since for the last almost 30 years I've been making video games. Prior to that, I was in the music business. I bring that up only to say that music and music production has been my passion since I was a kid, and somehow I ended up in video game business, which is a whole crazy story that if you get me drunk, I'll tell you someday. So, like I said, I'm going to talk about this thing called Patchwork. As well, Patchwork's going to be kind of the background character, and I'm going to be talking about how it was that we were able to make this thing. And in order to do that, I think the easiest thing to do is to show you a video. So I'm going to start out by showing you a video that shows you what Patchwork is, and then I'll explain to you how we made it. So give me 1 second to switch my screen around here. Sorry, that's small. Why isn't it? Okay, here we go. Bring this up. Bring that over there. I just realized I didn't do that first. All right. I think this will play. Come on, don't do that. Do that.
Here we see a player in Fortnite creative mode, and they are dropping a drum sequencer. There's nothing to hear because they don't have the output of the drum sequencer going anywhere. Now they drop a drum instrument, and then connect the MIDI output of the drum sequencer to the drum instrument. Again, they still don't hear anything because the audio output from the drum instrument isn't going anywhere, so the next thing they need is a speaker. Audio out of the instrument into the speaker. There you go, you can hear it. Now they can head back and actually play with the step sequence and adjust the pattern. And now over to the instrument to change the palette. Maybe adjust the mix. Now let's skip ahead and watch them create a more sophisticated piece of music. Create a bass part with some sustains. The same chord is looping over and over again, so let's add a chord progression by turning on the progressor. Sounds pretty good. Let's go add some more parts. Yeah, we'll want this one following the chord progression as well. something a little more complicated. Here, the player has created a pretty big patchwork, and they're going to effectively live perform this patch by turning on and off various devices, adjusting some knobs. Really going to dive into the deep end. The next thing we're going to look at is creative mode, where the player has set up a giant patchwork and they've used the other creative mode systems and devices to create these switches. These switches are connected to a variety of different knobs and switches on the patchwork devices. So you can see as they flip the switches, we hear the music change. What's going to happen is they're going to actually create a game, and they're going to have the game logic flip these switches behind the scenes. And now the player will do the exact opposite. In the previous example, we had the game systems telling the music to change. Now we're going to have devices in the music patchwork that send messages up to game systems that can then move objects around the scene and trigger animations based on input from the music system. And we can use that same patchwork to drive a completely different style of gameplay. All of that in a massively multiplayer online game where the players can collaborate in a creative space, all interacting with the same patchwork. Here we see a player in Fortnite creative mode, and they are dropping a drum sequencer. There's nothing to hear because they don't have the output of the drum.
I think we've seen just about enough of that. That is patchwork. And you can, let's see, where's my mouse? Come on, there we go. We're back. Patchwork, all of the devices in patchwork are well documented online. If you search for Fortnite patchwork devices, you can learn all about how to use patchwork to do all the stuff I did or showed in that video. Like I said, we're not here to talk about how to use patchwork. We're here to talk about how we made patchwork. So patchwork is the result of 3 teams getting together at Epic Games. One was Harmonix. Harmonix was the original developer of the Guitar Hero franchise, Rock Band, Dance Central. We were known for making music games, rhythm action games. We were acquired by Epic 2 years ago. The first part of this, first of these 3 teams was a gameplay feature team, and the creative lead on that was a guy named Ryan Challenor. Some people in this room might recognize that name. Ryan made a very popular open source synth called Bespoke Synth. You might have heard of Bespoke Synth. Ryan created Bespoke. But he's an employee full-time, or was of Harmonix, now of Epic. Harmonix Gentech Audio Team, that's the team I lead. My responsibility when I was with Harmonix, my title was Music System Architect. Now I'm a distinguished audio engineer at Epic. I don't know what that means other than you're old, I guess. I don't look or feel distinguished. So my team is responsible for building all the music features and music technology behind the Harmonix titles before we were acquired, and now bringing those features and functionality to the Unreal Engine audio system. And the third team is the Unreal Engine audio team, which is based in Seattle, which built a lot of the lower level tech. The underlying tech behind that, perhaps obviously, is Unreal Engine, and then moving up the stack from the bottom up is MetaSounds. And then on top of MetaSounds, we built this plugin called the Harmonix MetaSound plugin. So I'm going to talk about how we were able to use those two systems, Unreal Engine and MetaSounds, and build upon them to create this music plugin. So Unreal Engine, some of you may be familiar with game engines, Unity, Unreal, et cetera. Think of this as your juice for making video games, right? So Juice gives you this framework for that abstracts away a lot of the differences between whether it's a DAW or an operating system, a piece of hardware. That's what Unreal Engine gives us in the video game space. So we get all of these like low-level things. It's not just the convenience of having that stuff abstracted away. It's actually almost perhaps more important that we have to use all of these systems because we have to cooperate with all of the other game systems, right? So when we're writing our music software or audio rendering tech, we have to make sure that it's performant, not just because people maybe want to pile tons of plugins into their DAW, but because the game engine is trying to run physics and particle systems and simulations. There's a lot going on down in the game engine, and so Unreal Engine gives us all of these things. We have to think about them when we're just, thinking about how we're going to make a system like Patchwork or a system like the Harmonix Music plugin, because we can't just reach down and start hitting standard libraries for things, right? You're not going to find any mallocs in our code. You're not going to find any place where you're not even going to find any place where we call much of the standard library. You're not going to see standard shared pointer or standard malloc. You know, that stuff is gone. We're going to be calling Unreal versions of all of these things so that we can collaborate with all the other teams building systems. Now, I've kind of split up some of the Unreal Engine features. I'm not sure the Unreal Engine team would even split them up this way. I think of these as kind of really low-level systems, and I think of a level above those, like higher-level systems built on top of those. And these become key, which like wrap all of those lower-level systems. So asset pipeline and editing. You know, we're going to want to make music in this thing. We're going to want to bring in MIDI files, right? So how do we bring in MIDI files into a game, and what does it mean to bring them in, and how do they get cooked, and how are they represented on disk, or when they're served up as a downloadable piece of downloadable content, or how are they streamed? So I don't have to think a lot about those problems because Unreal Engine gives me like an asset pipeline. I want to be able to touch and change musical parameters. I want to have the user interact with something on the screen, and that's going to result in settings that should change down in the audio rendering system, which means that I need ways for those settings to be reflected to the scripting system, through serialization system, and down through running DSP code. Memory allocation I touched on earlier. So there's garbage collection. I have to think about how I'm using memory, and I have to use this garbage collection system. And then there's this Blueprints. Blueprints is Unreal Engine's visual scripting system, right? So this is going to tie together those user interactions that I was talking about with underlying DSP code that's actually doing rendering. There's lots of stuff in here, but I'm just going to skip ahead to MetaSound authoring. And so continuing to move up our stack, I started with Unreal Engine. We're going to start moving up and start talking about Unreal Engine Audio. Now, Unreal Engine Audio, there's lots of stuff in Unreal Engine Audio. If you were to go to Unreal Engine, download it, and start looking through the docs, you're going to find tons of things. There's lots of stuff in here. There's stuff related to the final mix, what the player ultimately hears. There's spatialization and attenuation, right? You have diegetic sounds, you have non-diegetic sounds, you have sounds that appear in the scene that have to be 3D localized, you have sounds that should just be coming out of the stereo speakers. We want to, you've got support for plugins. There's, multi-platform asset management, as it says there. The thing we're going to concentrate on here today is MetaSounds. Because that's the place where, that's the kind of the newest bit of tech. It's the new hotness at Epic, and it's ripe for the kind of work that we're going to need to do in order to create music like you saw in Patchwork in a game. Now, out of the box, MetaSounds comes with, well, let me just show you MetaSounds. First, one more word about it. This is just a copy and paste job off the website. That's what MetaSounds is. key here, as I said, is that MetaSounds offers users customization and third-party extensibility or first-party extensibility. So we eat our own dog food, as they say. So with that, let me do a quick switch over and show you a little bit about MetaSounds, in case you've never seen it before. I gotta do that, and then I have to go here, and I have to say, duplicate these displays, and I think if everything worked correctly, you are seeing a MetaSound editor. MetaSounds is based on the concept of a directed acyclic graph of audio signal processing. Whoa, something just changed. Let me try that again. We're back.
Key changes.
Oh, thank you. Right, so what we can do in this space here is create a directed acyclic graph of audio signal processing nodes. So, for example, and this might be a little bit hard because my mouse is all the way over here. I'm going to type saw. So, for example, if I want a sawtooth wave, I can just drop that oscillator over here and come to my output, and let's see if we have any audio from the laptop. Sorry, is that really loud? Well, if it's really loud, what we can do is, why don't we just drag off of here and multiply this by a float. And then why don't we take that into the output? And why don't we take this float, and why don't we make it an input to the graph? Why don't we call it volume? And then why don't we play it, turn it down to a reasonable level. Okay, so a couple of things about what I just did there. I think you understand what I'm doing as far as building a graph here. One of the things, so let's talk about this volume knob I just made. I said I wanted to create this input to the graph called volume, and it gave me this knob, which is really just an editor convenience. But that brings me over to the left part of the screen here. So I have, my MetaSound has the ability to take in inputs and write outputs. And these inputs can be any number of different data types. I can input bools and floats and things like that. Same with the outputs. The other interesting thing about inputs and outputs is inputs and output sets, if you will, can be created as interfaces. So it's possible for me to write C++ code that says, hey, I want to create an interface for audio. So let's say I was going to make a car sound, right? I was making a racing game. And I wanted to have my sound designer to go create engine sounds for different vehicles. So I'm not saying this is the way you would do it. I'm just using it as an example. What I could say is, okay, here's the thing. Every engine sound you create should be able to accept an RPM, a load, a speed, a number of cylinders in the engine, etc. So I could, as a coder, define that interface and say, this is the interface that you need to implement for all of the engine sounds that you make for your cars. And then when the sound designer comes in here to the Unreal editor and they say, I need to make a new sound, they could click on this interface button, click on it, and what they would see in this list is the car sound. And when they selected it, it would populate these inputs and outputs with the things that are available to them to control the DSP. Everyone's with me so far? So I'm not going to go into the details about how you create those, but I will come back and reference this as we talk about patchwork. Maybe even some of you are starting to build some thoughts in your head about maybe interfaces could be useful if you were going to build a system like patchwork. So the other thing I want to say here is that out of the box, as it stands right now, if you were to go download MetaSounds, you would find lots of these nodes, like DSP nodes, all the classic ones. You find filters and oscillators. There's things for dealing with triggers that you can use on, let's say, for example, I were to drop and say, we want an ADSR on this. So we want an ADSR, here's our ADSR. And we're gonna take a trigger for the attack. I'm gonna make that an input. A trigger for the release, I'm gonna make that an input. And then I'm gonna multiply this by audio. And then I'm gonna take the audio from this into there first, and this into here. We don't hear anything, right? But the oscillator is running. You can tell the oscillator is running, right? Because that line got thicker. But if I go over here, I can trigger the envelope. I can trigger the release. So it may be that we don't want that oscillator sitting there running because it's using CPU cycles, right? If it's sitting there and running. So I might want to do something like, let's see, sorry. I'm having trouble with the mouse. Go do the thing I want to do. So what I want is a trigger toggle. And the output of this go to enable. And the output of when it's attack, trigger on. And when it's done, trigger off. And now the oscillator is not running until I trigger that. And now the oscillator is stopped. Okay, I think that's enough of MetaSounds. I think you probably get the idea. The out-of-the-box components or nodes, you'll hear me refer to them as nodes or operators, include a lot of standard DSP stuff, but there's no music stuff in there. There's no MIDI. There's no MIDI clock. There's no MIDI events. There's no transport. So this is what we had to start with. We started to think about how could we create something like Patchwork. And with that, I think I will switch my monitor back and keep it. And then I can go here. So let's talk about that MetaSound stuff we saw. So the source code, like everything in Unreal Engine, is available to all licensees. You could download it today if you wanted to, which means that the source code to MetaSounds is available. And MetaSounds can easily be extended with custom data types and nodes/operators. So this is the thing. Inputs and output pins on those nodes that we saw are completely flexible, and we can define our own. There's basic data types included in the system. But like I said, we want musical data types. So what we want to do is what are those pins? Those pins are data write references and data read references. We need to create this thing as optimally as possible, right? We can't have copying happening, et cetera. So what you saw there are the output pins on nodes are data write references. They are owners of a spot in memory, and all of the things downstream receiving that have read references to those same memory locations, right? So you can think of them as const references to the memory. That's how inputs and outputs will work. So let's go back here. You have a thing you want to be a pin on a MetaSound node. Here we have a doohickey, and it's got some standard, some basic, members of the struct, a bool, an int32, and a float. And in order to make this thing available to me to put in my node as an input pin or an output pin, I just need this line 15 and 16 to start with. Well, I should say, to start with, I need that line 15 and 16, which tells MetaSound, which effectively that macro creates a couple of wrapper classes. The only one we're really primarily interested in right here today is this read ref and write ref. So these are two classes that are created as a result of using this macro. And we'll see more about those in a minute. But I also said, well, we want to be able to see this as pins, inputs and output pins on MetaSound nodes, but we also want to be able to create one of these, let's say, on the game scripting side and pass it down as information that is then used to modify the rendering. And in order to do that, how do I create one of these structures in our scripting language or in the visual scripting system called Blueprint? And we need just a little bit more markup for that. This looks a little more complicated, but it's really not. All I've added are some macros to this, right? It says, hey, I have this structure that's and I want it to be a blueprint type. That's the ustruct there. Line 38 is generated body, classic stuff. It's going to inject some code in there to make this thing visible to the scripting system and make it serializable. And then I have these, each of my members now has this uProperty markup, right? So now this thing is fully usable from script and from my MetaSound node. And the last thing I need to do is in some CPP file someplace, I need to have this macro that says register MetaSound data type. Now this thing is available and MetaSound understands that nodes may have this data type and that it understands how to deal with things like creating write references, creating read references, connecting pins of that type. Okay. So instead of switching my screen back and forth, I'm just going to stay over here. I think my next slide talks about a node, but I think I can just riff on that here. By the way, let me just check and see how I'm doing on time here. 47. I think I'm doing it okay. What time do I have until? I'm sorry? Till about midday. Okay. Okay. Right, so a node. Now, we're not going to go through all this code line by line. Really, the only point of, the primary point for bringing this up is to show it's different, okay, in a lot of ways than creating a juice plugin, right? But effectively, what you're doing here is creating, your node is an operator, and you're creating this operator, and as long as you create your custom class, my fancy operator, and I derive it from this template, which is one of these curiously reoccurring template patterns, right? It's like with itself as the argument for the template. And now I have to implement some basic functionality. And an entire node can be defined in one single CPP file if you want, right? So I'm gonna just quickly look at a few of these things and point out some things, but like I said, I'm not gonna go through this every single line of code. So a couple things to point out. Here are my inputs and outputs, right? So I said we had these classes that were created called read reference and write references. And you can see my inputs that I'm naming in pin, those are read refs, right? And my outputs are write refs. I want to write out, let's say, a trigger out, or I want to write out one of those structures that I showed in the previous example. So I have write refs to those. Fine, so I've got those as members of my class. Not going to go into this in detail. This is a static function. It basically tells MetaSounds like, hey, here's the information interesting about this node so that when you serialize it, it has a version number so we can deal with loading and saving and version changes, and some descriptive names and some help text, et cetera, so that when you're in that MetaSound editor, you get appropriate displays of naming, et cetera. And it can also be localized and end up in other languages. This is another static function. This is how MetaSound, those nodes that you saw in the MetaSound editor with the inputs and output pins, those were created dynamically. I didn't have any control over that user interface. If you really want to dig into the MetaSound code, you could create your own user interface for it. We just can take and define this get vertex interface function, and it will return this structure to MetaSound's system, so that it understands how to render that node in the editor, and it understands how it can build a graph then with one of those nodes in it, right? So here I'm saying, hey, look, it's got this input interface, a bool, an int, a string, a doohickey. The name, I can even say what the defaults are, so we can see here the default for the bool is true, the default for the track number is 1. I don't have any default for the string or the doohickey, and I don't need defaults for my my output vertex interface. Create operator is the third static function. And the interesting thing here, I think worth noting, is that, well, let's see, a couple things. By the time this function is called, the graph builder has built all of the upstream nodes. So what we see in this function happening is, this function is saying, okay, it's a static function. It's saying, okay, I need to instantiate one of these nodes. The first thing I'm gonna do is find out whether my inputs are connected to anything or not. And if they're not connected to anything, I would like them connected to like static initializations of like default values. So that's what this function call is right here. It's like, hey, I would like the read reference to what I'm connected to, or give me a vertex default. And you notice I only deal with my inputs. I can't really, there's really nothing to say at this point about my outputs because it's not built that part of the graph yet. It's going to come looking for my outputs later. Right now, it just wants to, it's just telling me about my inputs so I can reason about that, and I can ask it to create me data references. And then right down at the bottom of my static function, I'm calling my constructor. This is interesting to me because you don't have to define a standard format for your constructor, for your node class. And it's interesting because that means that when create operator gets called, even though you can, so what you could do is you can create an operator type, and you can actually have two different variations about how it runs based on static inputs to it. And so you could instantiate one of different class, completely different classes for those nodes at this moment, as long as they derive from T executable operator. So it's a way to kind of like optimize code based on inputs. You could look and say, oh, this thing is running in stereo, so I'm going to instantiate a stereo version of this, or this thing's running in mono, I'm going to create a mono version of this. Next thing, moving to the constructor that might be interesting, the constructor is taking those references to the read references, but I didn't talk about above the write references. Here's how we actually create the write references. So whereas I was asking the graph builder to tell me about the read, to connect my read references up the stream, here I'm actually instantiating new write references. This is going to actually create the memory for those outputs. Binding inputs and outputs I'm not going to talk about much. It's a complicated topic, but bind outputs is probably worth just saying that I talked about what happens down, when you're being constructed. When the downstream operators get built and they have read references to your write, the graph builder needs to understand what it's connecting those write references to, right? So it's got to call your bind outputs and say like, hey, I understand you have this output. What's the actual location in memory for that thing? And you can say here, I'm saying, hey, I've got a member called output pin, and that's the actual memory that's got the output, the data that this downstream node is looking for. And then, just very quickly, we have the simple stuff. That's the hard stuff. The simple stuff is doing the actual DSP, right? The simple stuff is like, okay, great, you're told to reset. All I wanted to show here is like, in reset, I'm basically putting myself into a good internal state, like my B0 is being set to true, and I'm setting my outputs to a decent state, right? Like there's things downstream that are looking at my outputs, and if I'm being reset, I want them to be rational. And execute, right? Execute takes no arguments because it doesn't need any. It's been wired up. It's got read references to things that it cares about processing. It's got write references to things it's going to output. Here I'm conditionally checking whether the enable pin is true or not. If it's false, then I check and see whether I'm zeroed. If I'm not zeroed, I reset. Otherwise, I just return early out, right? I return. And all I'm trying to show here is, right, like some things you're just going to pipe input to output maybe, like my should do anything out is the same as my should do anything in, but maybe I'm like my output this many times is the result of taking like the input this many times and dereferencing another input pin, which is the track number, and et cetera. So this is all obviously just made up hokey code. The point is you're just looking at your read references and putting things on your write references. With that, I think I will switch back to the presentation. See where we ended up. Come on. So I already spoke about that, did that. Right, so what did we do at Harmonix when we came on board and we started to look at bringing the Harmonix music code to MetaSounds, and we had a guy like Ryan Challenor on our game experiences team saying they wanted to create a DAW in a video game, other than say, you're insane, it's not possible, we couldn't possibly do it. We said, okay, well, what do we need? We need some data types in MetaSounds. We need a MIDI asset, which is like a MIDI file. We need a MIDI step sequence asset, which is kind of a MIDI file, but just in step sequence form. We need music timestamps, like bar and beat. There's no bar and beat to pass around on pins. We could pass a separate bar and beat on two separate pins, but that just doesn't seem to make any sense. We want a music transport. We want a MIDI clock, and we want a MIDI stream. And once you have those data types, you can do things like this. You can create a MetaSound node that says, hey, take a bunch of standard trigger inputs. Remember, trigger is part of the standard set of things that we can bring in, and make a transport. What's the point of this? Well, if I don't have this, then everything that plays music is going to have all of these pins, and not only have all of these inputs and deal with them, but also make sure that they're all rational, right? Like, what do you do if you get told to pause and you're stopped already? What do you do if you get told to play and you're not prepared? So we said we don't want all of those pins on all of our nodes. We'll create a custom data type for music transport, and we'll have one node that can take all of these input triggers and turn them into rational transport messages. Once you have a transport, then you can take that transport into something like a metronome, right? And you can say, hey, I want a metronome that has 4 bars long, and it has, or if it's looping, or it has, what's the time signature, what tempo do I want it to run at, et cetera. And from that I can then generate a MIDI clock. Or I might want to create a MIDI clock as a result of looking at a MIDI file, right? Because we're Harmonix, we make rock band. We got lots of music that was recorded in the 70s, and people experimented with various things. Not a lot of constant tempos, right? So in that case, you want a MIDI file to give you a tempo map. So you send a transport into a tempo map MIDI clock generator with a MIDI file, and what you get out is a MIDI clock that's running at the varied tempos in that map. And once you have a MIDI clock, then you can create nodes like this that take in a MIDI clock, and you tell it, hey, I want a grid on subdivisions. Like, I want a grid that gives me a trigger output every beat, or every measure, or every other measure, offset by 1 beat, and things like that. Or you say, oh, I want a MIDI clock, and I want to trigger at a specific timestamp, like bar 5, beat 3. Now, once you have a MIDI clock and a transport, then you can do things like entire MIDI players, right? Give it a MIDI file and take a transport in and a clock in and output a stream of MIDI events. And you can do that with a MIDI file or a step sequence. And once you have a MIDI stream, you probably want to do things like this, like select between 2 MIDI streams or merge 2 MIDI streams. Or transpose all of the node ons and node off messages up or down based on something like a note progressor in Patchwork, right? Or maybe for debugging, log the stream so you can actually see all the events that are pouring through the whole system. Or have a node that actually does some real deep, hard DSP, right? So at Harmonix, we had this thing called the Fusion Sampler. It's our software sampling synthesizer. We've had it for years and years and years and years and years. It's highly optimized. It's got tons of stuff poured in there. It supports time stretching, pitch shifted, time corrected, pitch shifting, et cetera, et cetera. It's SIMD optimized for all kinds of different platforms. And we had this code base, right? And it deals with things like voice management and voice allocation. And we thought, okay, could we build that entire thing in MetaSounds? The answer is yes. Surely if you took the time, you could build an entire example of a graph that replicated all the functionality of that sampler. We already had it running, highly optimized, and ready to go. So what we needed to do was simply wrap it in a node that took a MIDI stream in and writes audio out. And honestly, this was trivial to do, given the code and examples and stuff you saw before for MetaSound. So all of that's in a plugin, and all of that is going to be available in the Unreal Engine distribution sometime in the spring. We have to get through a product release cycle that we're going through right now. But that's all going to become available. And so now, am I out of time? I got 5 minutes. Now we can talk a bit about Patchwork. And some of you are probably already putting together in your head all that stuff I just talked about how Patchwork actually works. We're probably starting to realize that this is what the devices in Patchwork are. We saw a guy dropping different modules, right? What is one of those modules? Well, it's standard graphics assets, right, that you would have in any game. It's a 3D model, and it's got scripts that deal with how a player would interact with that 3D model, buttons that can be pressed, knobs that can be turned, none of which is any concern to the MetaSound rendering, right? That's all just standard gameplay stuff and user interaction, controller input, et cetera. So that's what you see. What you hear is a MetaSound patch. And the blueprints is the thing that's connecting the two together, that scripting language. So a Patchwork device is this complicated guts of a MetaSound, and that thing what it looks like on the screen. And remember I mentioned interfaces? If you think about it, Patchwork had a couple of different kinds of devices, right? It had a device that could generate MIDI output. It had a device that could take MIDI output and give you audio out. So that would be an instrument device. It had devices that could take MIDI in and have MIDI out that would do transposition based on chord progression. It had devices that could just take audio in. Well, each of those kinds of devices was defined as an interface. We just sat down and we said, talked to the designers about the kinds of devices they would want to make. We could create this interface and we could write it up in C++, build it into the editor, and from then on we could just say, hey, when you want to make a new synthesizer device for Patchwork, go ahead. All of the other stuff, the graphics and everything else, like I said, that's all separate. But for the MetaSound patch, just go create a MetaSound patch and add that interface to the MetaSound patch and use that interface to render your audio. And the patch itself, that giant patch that's created, is this one music manager device that you don't really see. It was kind of off in the background, and I didn't draw anyone's attention to it. But what that thing does is it's the thing that knows about all the devices the player has dropped and knows about all the connections that have been made between the devices, and it turns that knowledge into a call to the MetaSound system to dynamically build the MetaSound graph at runtime. So what I was doing in the editor, some of that's done by a sound designer, right, to create one of the devices, but as far as the patch of all of the devices all connected together, that's happening dynamically at runtime. So the moment a player drops a device and they connect a wire to it, we generate a new graph and start rendering that graph. I just said all that stuff. Oh, the one other thing it does is it keeps the clients in sync. I think I could give 3 talks on how we actually how this all works in multiplayer, because it does all work in multiplayer. And what happens is that Patchwork Music Manager has to keep in touch with a server, and the server keeps track of where all the clients are in musical time and tries to keep them close to being in sync. That's important because server is authoritative in games, which means that if you want one of those patches that moves devices like you saw in my demo, those walls moving to the beat, that's not happening on the client, it's happening on the server. If it's gonna happen on the server and it's being driven by music, yeah, that's hard. In summary, bunch of tools you can use to build audio rendering system for games in Unreal Engine. MetaSounds is usually powerful for creating DSP graphs, highly customizable. I would suggest you guys might want to go look at it and see whether it's something you can do there. We have a Harmonix music MetaSound plugin that we're going to be making available. Patchwork is available now in Fortnite Creative and UEFN if you want to go play with it. And by the way, as a separate little note, some of you may have a super fancy synthesizer algorithm, something you're really proud of, you think is really awesome, and you think maybe a Fortnite player should be able to drop into a Fabric. And if you do, hit me up. Maybe we can talk and figure out if we can make your DSP work in Patchwork. I don't know if we have any time for questions and answers, and I don't know if I can actually answer any questions, but okay, I can try. Was that too much? Thank you.